Hi everyone, it's been a while, but I thought it would be nice to finish this tutorial series, so welcome to the 7th part of this geometry node donut. You've come a long way with geometry nodes, so congratulations to you. Great job. In this part I want to introduce you to one of the most exciting nodes in recent Blender releases, loops, or as it Blender called, the repeat zone, or just repeat in the new Blender 3.3 release. Repeat is a unique combination of nodes that allows you to repeat some parts of your network to create unique results. I will show you how it works and how to use it, along with a few tips on this simple example. So, we have a simple default cube. I will now add a repeat node by searching for it. This is a repeat nodes duo. It consists of two nodes, an input and an output, and also a zone between them, here. So, how does it work? Let's plug our default cube geometry into the first node, geometry input, to find out. One of the most important settings here is the iteration number. It tells the repeat zone how many times it has to repeat itself. If I change it to 12, everything that is between the input and output nodes of the zone is repeated 12 times. Let's add a simple set position node to better see what I'm talking about. Let's add a slight offset in the z-axis, and now, if we change the iteration number, as you can see, we are offsetting our cube more or less. What is happening is that in the first iteration, we are offsetting the cube by 0.1 meter, and then this offsetted geometry is taken from the end of the zone to the beginning. In the second iteration, we are offsetting the cube once again. This is extremely powerful addition to the geometry node system, and you can do a lot of interesting stuff with this. Besides changing geometry with simple nodes, we can also use fields to guide our repeat zone and even create physics simulation, but for that, however, the better choice will be the simulation zone, which is correlated to the scene timeline. Let me show you this example of how you can use fields inside the geometry node's repeat zone. So, I will delete the set position node and instead use the extrude mesh node. Let's add it. Wow, a lot is going on. Let's decrease the number of iterations to better see what we are doing. I will also add a scale elements node to scale the top faces of the new extrusions. To avoid extruding every single face, I will use a random value as a selection for the extrude mesh node. What I want to do now is to make each next extrusion a little bit longer. To do that, I will need to loop attributes. As you can see, we can drag and drop another wire from out the repeat zone. I will add a math node and connect it to the repeat zone. Let's change the mode to add. Now, with every iteration of this loop, the value is going to increase by this amount. We can preview it inside the spreadsheet editor. In the first iteration, we have a base value that we can set here. Then, we are adding to it our value here. This value then goes to the end node of the repeat zone, and in the next iteration we are starting not with the value we set here, but with the value that goes to the end of the repeat zone. We are looping this value, this attribute, so the data flow looks like this. With each next iteration, this value gets bigger. Let's test it by plugging it in as our extrude offset scale value. As you can see, these smaller extrusions are getting longer. When we increase this value, or even better, change it to multiply, the extrusions will get even longer. So, this is the basic concept behind the repeat zone in Blender. So, what we are going to do with this repeat zone for our donut? we will use it to fix one error that we currently have inside our sprinkles system, the intersecting sprinkle particles. If you look closely at our sprinkles, you will notice that some of them are intersecting. We can try to increase the minimum distance at the beginning of the sprinkle setup, but then our sprinkles start looking too even, a little too low density and a bit boring. What I intend to do is to leave the particles as they are and then delete the particles that are intersecting. And for that, we'll use the repeat zone. So, without further ado, let's start. First of all, I will drag a new reroute node from our sprinkles. Now, I will add a new repeat zone. So, how should our system work? Let's break down our task into smaller steps to make things cleaner. First, what I want to do is iterate through all my sprinkles. I will select one and check if it's intersecting with any other sprinkle. If yes, I will delete it. If not, I will add it to a new sprinkles group. So, first of all, we need to iterate through all sprinkles. To do that, we need to know the current total number of sprinkles. We can get that information using the mesh island node. It will give us information about the individual mesh island count. But there's one small problem. We cannot connect a field to the iteration number of the zone. We need a single value for that. For this, we can use simple workaround with the help of attribute statistic node. Let's add it. Now, to make it work, we need to make two more connections. First, let's connect the island count output to the attribute input. As you may notice, all output of the attribute statistic node are single value ones. They are circular shaped. So, what we can do is take the max value and use it as our iteration number. Thanks to that, we ensure that we will iterate through each sprinkle. Now, we need to work on every sprinkle individually. For that, we need to divide the work in our repeat zone into three main steps. First, we separate a single sprinkle, different for each iteration. Then, we'll perform a check on it, and after that, if it is not intersecting with anything, we will join it to the new geometry. So, let's first learn how we can separate our sprinkles and join them back together. To separate geometry, we'll use the delete geometry node because we don't need the other separated geometry. We only need a single sprinkle. Now, we need to create a selection. For that, we can again use a mesh island node. If you look at it, you will notice it also has a second output, island index, which is a unique number assigned to each mesh island. So, in our case, it will essentially be a sprinkle ID. We can easily use it to separate a different sprinkle at each iteration. Let's add an equal node and plug into it our island index and iterations from the repeat zone. With these fields, we can select a single sprinkle. However, for the delete geometry, we need to select an inversion. So let's add a boolean not node and put it after the equal node. Now let's plug it into our delete node. Great. Now, from this output, we are getting a different sprinkle at each iteration. Now we just need to join them together with a simple join node. Let's add it and plug it into the output of the zone. Now, let's plug these two cables into it. So, we are back to where we started. Great. So, what is going on here, you may ask? What we are doing now is basically separating the first sprinkle and adding it to a new geometry. Then we separate the second sprinkle and join it too. And we are doing that for every single sprinkle, ending up with basically the same geometry at the end. So, the last thing that we need to do before joining our separated particle into the particle group is to check if it's colliding with our current new geometry of the particles. To do that, we will need to check if any point of this separated sprinkle is inside the newly generated sprinkles. For that, we will need to develop a custom group named IsInsideVolume that will tell us if the geometry is inside of another geometry. This might sound complicated, but it will be just a few nodes, and after all, after the creation, you can just reuse this group in your next project without need to worry about how it works inside. So, how do we check if the point is inside another geometry? With a raycast node. It is a really effective solution, and I will show you how it works. First of all, we need a raycast node. What this node does is shoot a ray from the currently evaluated element, like a point, and then this ray can search for a hit with a specific target geometry. It can then give us information about that hit, like if it hit at all, the hit distance, position, normal, or even attributes. It's a really fast node, which makes it extremely useful because we will gonna perform this check each time for each sprinkle, so a lot. So, let's shoot rays in random direction with a random value node set to vector. Now, we need some target. And for that, we will use the geometry output from the first repeat zone node. Thanks to that, we'll make sure that before adding a new sprinkle, we will check if it is not colliding with any existing ones. So, let's connect it. Now we have our source, target, and the ray direction. What's next? To check if the point is inside the volume of another sprinkle, we will use normal information. For better understanding of this, I will show you this example. Let's imagine that we have 2 points. One is inside the cube and one is outside. We are shooting the rays in random directions. Let's assume that both of these rays hit the cube. Let's draw the normal vectors now. If you compare the angle between the ray and normals, you can notice that if the point is inside the volume, the angle will be larger than 90 degrees. And if the point is outside the volume, the angle will be smaller than 90 degrees. Knowing that, it is really easy to check if the point is inside or outside of the volume. Now, how do we check that between two vectors easily in Blender? With the dot product vector math node. What is the dot product? It's a math operation that basically tells us how the vectors are oriented to each other. If the value is equal 1, then they are facing the same direction. If the value is equal to 0, then they are perpendicular. And if the value is equal to -1, the vectors are in the opposite directions. Knowing that, we are ready to finish our IsInsideVolume group. Let's add a dot product node and connect it to the hit, normal, and random value node. Let's plug it now as our output and name the socket. So, we now can check if any point is in or out. But we don't want to delete only a few points of the sprinkle. If any point of a sprinkle is colliding with the rest, we want to delete the whole sprinkle. So we need to add one more thing to our repeat zone setup. And that is the accumulate field node. Let's add it. This is a little bit more advanced node. It allows us to analyze fields and use them in a very specific way. What we will use is the total output of this node, which basically adds all fields within a group ID together. So for example, we have a cube and each point of that cube stores an attribute with a value of 1, the accumulate field for the point domain will be 8. So, why do we want to use it? Because now we can add all is_inside_volume values together for each sprinkle separately, and if the value is larger than 1, that means that some point is inside the volume. So, let's connect to accumulate fields the is_inside_volume group and as our group ID the island index. With the selection, the last thing that we can do before is change the accumulate field type from float to, I was gonna say boolean, but there's no boolean actually. So it will work anyway, so we can leave it at float. So let's just add another delete node after the previous one, and as the selection we're gonna use the total output. Let's wait a second to calculation. As you can see, some sprinkles disappeared now. If we zoom in, we can see that most of the sprinkles aren't intersecting anymore. The system is not perfect, but works pretty well. We can try to increase our original density a little bit now to make more not intersecting sprinkles. But remember, our setup is pretty heavy, so don't make too many of them or Blender may crash. So, this will be it for this lesson. I hope you learned something new and had fun with the repeat zone. These new repeat nodes are a really powerful addition to the geometry node system and can be really useful in many different scenarios. In the next tutorial, which I hope will come really soon, we will add additional final details to our donut and also create some final materials. So, stay tuned. Thank you so much for watching and see you again soon. Bye!